of you, and a couple of you are feeling kind of nervous about the test. So what you'll notice here, I put a link to a calculator on this. So if you want to, while you're taking the test, open that in a new tab, leave it over here so that you can use it during the test. It's a good scientific calculator on Desmos.com, but if you've got one on your phone or just like another one that you like, use that. That's totally fine. But this is a good calculator. It's got squared, it's got square root, and all those fun things. All right, I'm going to start the practice test, and I'm going to go through every problem on this practice test. And if there's a problem that you feel like was particularly tricky, or that even with my explanation it still doesn't make sense, type in something on the comments. I'm reading those as we go along, and I can address that. Okay, so let's look at these questions like numbers 1, 2, 3, and 4. You are looking for lines of symmetry. Now, on the written test, I would have just given you a blank shape and made you draw in all the lines of symmetry. So let's just like breathe a sigh of relief how much nicer it is that you just have to choose which ones are lines of symmetry. So with a line of symmetry, I'm looking for one of these dashed lines to cut the figure perfectly in half, where I could imagine that if I were to go along this red line and fold the figure in half, would it perfectly land on itself? So if I look there, I've got my red line, then there's 1 side, 2 sides, 3 sides, 4 sides on the left side of that red line. And then 1, 2, 3, 4 whole sides on the right side of that line. That's going to reflect perfectly. This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-sided figure. So with 10-sided, remember it goes from flat edge to flat edge. Now this one, the blue one, does go from flat edge to flat edge, but there's a major problem there. It's definitely not down the center of the figure. So we've got 1, 2, 3 edges above it, and 1, 2, 3, 4, 5 edges below. So it's asking which of the lines is a line of symmetry? Only the red one. Okay, then the second question, how many lines of symmetry does it have? Well, this figure had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, and we said that the number of lines of symmetry matches the sides of the shape. So if there were 10 lines of symmetry, or excuse me, if there were 10 sides on this figure, then there would be 10 lines of symmetry. Now the next one, what is the shape's smallest degree measure for rotational symmetry? The way that we found that was we started off by, we started off by doing 360 degrees, which would be a full circle. So 360 degrees takes you in an entire circle, which obviously is good rotational symmetry. If you were to go all the way around, which is a pretty cool trick, I guess, if you were to do that on like skis, also terrifying. But if you did it in 360 degrees, it'd be a full circle. But we want to know how many twists you could do in between there. And since there were 10 sides, you could do 10 total twists. That was a lot of T's, 10 total twists. So I am going to come over here to my calculator, and I'm going to say 360 degrees, and I'm going to divide that by the 10 sides on the figure. And when I do that, I get 36. So for question number 2, the second part here, the smallest degree of measurement is that 36 degrees. So I do 360 divided by how many sides were on the whole figure, which gives me 36. All right, now I'm not making you write in the degree measurement, but you do have to write 36. So yeah, you can't put the symbol up there. If you try typing in letters, apparently it lets you, that's upsetting, but you are only supposed to type in numbers, no labels. Okay, any questions so far on these ones? Because I'm going to clear this off and keep scrolling down. Like I said, open up the chat figure if you want to say anything, or if you want to like tell me that you have a question that you want to say out loud, just chat it in there or unmute yourself quickly. But let's move on to the next question. Number 3 is a lot like question number 1. This one I think is pretty simple to see which one's a line of symmetry. There are 1, 2, 3, 4, 5, 6, 7 sides on this figure. And a 7-sided figure needs to go from a vertex or a corner to a straight edge there. So this blue one also is the only one that looks like a line of symmetry because it would cut this figure perfectly in half. The red one, if you tried folding along that red line, it would be like a giant side over here and a little bitty side there. And when you fold that in half, it wouldn't work out nicely. So I'm only clicking the blue one on that. Okay. On number 4, we said that this was a 7-sided figure. So how many lines of symmetry does it have? 7, because the lines of symmetry matches how many sides are in the figure. Okay, now I'm gonna use what we talked about on that last problem. I will start with a 360 degrees. That would take it all the way around in a circle. And I need to divide, not by 10 this time, by 7, because it's a 7-sided figure. Now, I know this is going to give me a really wonderful decimal. 360 divided by 7, because there are very few numbers that when you divide by 7, you don't get something really ugly like this. This is kind of cool, by the way. This button over here says convert to a fraction. Before I do that, I want to look at this. This is 51.4. I think I asked you to round to the nearest tenth. So 51, hold on, I want to make sure what number was after the 4. 51.4, and do you notice that there's a 2 right after the 4? That 2 is not going to make the 4 round up to a 5 because the 2 is too low. So my answer is 51.4. Now, me and Mr. Bodley both agreed that we weren't going to be too picky about rounding. We want you to get as close as you can with the rounding, but if you are panicking that you are having a hard time with the rounding part, don't worry so much. We will look through those answers, and if it looks like it's close enough, or if you round it up instead of down, we won't be as harsh on that. We want to make sure that you know how to do the 360 divided by 7, and if your answer is in that ballpark, you'll be a-okay. But I do want to show you this. Click that button, it switches it back to the lowest possible fraction, which is really cool. So Desmos, awesome calculator. Unlike next year in the 10th grade, remember that, this is a good calculator. Okay, so we had 51.4. I'm gonna move on to the next problem. Again, if you got any questions, let me know. Okay, I love these problems. I don't know what is wrong with me. Just kidding, I do, it's that I love math. Okay, write a congruent statement for each pair of triangles. I gave you U, V, W. And I told you to mark these things up. So notice U has a single arc in it. V had 2 arcs in it. And W here, I'm not looking at that side. I'm just looking at this side for W. It has 3 marks. Okay, now I gotta get rid of that other stuff. There we go. I need to find the triangle on the other side that goes in that order. 1 arc mark, 2 arc marks, 3 arc marks. So if I go to that side, the 1 arc mark is over here first. So I know that R is going to come first because it had a single arc. Then T has the double arc. So I go to T next with a double arc. And then W is this last corner, and I go to W last with the triple arc. Now, you can't draw the arcs and stuff in this box. It just says type the 3 letters in the correct order. All right, so I've got R, T, W. And the test, I just always write them in caps. I think the test accepts caps or lowercase. Don't like mix it up between the two because that would be really dumb. Just don't do that. Okay, if you got questions, ask them. I'm gonna move on to the next one. Write a congruent statement for each pair of triangles. On this one, I'm using that same format. So I will start by going from D to B to Q. D was 1, B was 2, Q was 3. So I had 1, 2, and 3. So now when I go to these, D is first, B is second, and C goes third. So again, I was trying to match up the order that the arc marks are in on both of these congruent statement pieces. So I can put those in the order D, B, and C. D, B, C. All right, this should have been really easy on the practice test stuff. I hope that this is the part that you feel really confident about. And this would be a great time to, like, I don't know, write a note, or if you have like notes printed off, use those on the test, because the notes that we used on this, they'll make you ace this part of the test. All right, let's look at the next problem. All right, this is probably where I start to see some mistakes on the practice test and on the test. So let's look at these. State if the 2 triangles are congruent. If they are, state how you know. So I gave you a whole list of congruent statements, and I don't even have them with me right now, but I hope that some of you have them with you right now. Let's talk about them. The ones that you are allowed to use, pull up your chat feature. I want you to start typing them into the chat. So if you like, I'll get us started. The first one that we are allowed to use is SSS for side, side, side. Wake up, ninth graders, and type in some other ones that we're allowed to use. Side, side, side totally works. What other ones are we allowed to use? Thank you. Whoever said they're all listed there. Okay. Yes, they are. But not all of those are usable. Okay, I see someone said side, angle, side. Okay, so side, side, side is allowed. Side, angle, side is allowed. Thank you. Angle, angle, side. And then the one that's kind of like side, angle, side, right there, angle, side, angle. Okay, so those are the options. We just have to see what we've got here. So on my first triangle, I've got a side with 1 tick mark, a side with 2 tick marks, and then a side with 3 tick marks. This one on the left side is set up to work for side, side, side. I have to see if the right triangle is also set up to do side, side, side. If they both have the same markings, then side, side, side works. If this one were to have like 2 sides and the angle between, then I would say no, because they both don't follow the same rule. So on this one, I've got a side, then a side, and then a third side. So it was pretty easy to see on this one, but these are congruent because of side, side, side. Because the first triangle had a side, a side, a side, and the second triangle had the same 1, 2, 3 markings. All right, let's look at another one that's not quite so obvious, because when we start to get to ones like this, where you have to fill in your own work on some of it, it gets a little bit more tough. Okay, and if you missed this one, feel free to like ask questions. Again, this was, when I looked at the results, this is one that was more commonly missed. So what do I have thus far? I've got an angle, and I've got this side. And you might be thinking, not congruent, because you can't do it with just 2 of them. Well, that's not actually all that there is. There is a third thing that needs to be marked. And it's something that we talked about in the 7th grade a lot, and then it's something that we reviewed in the 8th grade, and now we've reviewed it in the 9th grade. This angle here, these 2 angles, they have a relationship. They're vertical angles. If they are directly across the vertex from each other like this, that means that they are congruent to one another. So look out for stuff like this. Look out for vertical angles. Look out for a shared side that's going to be congruent to itself. But that vertical angle makes things even more fun, because now I've got 2 angles, and that side there is included between the 2 angles. Everybody say hi to Mr. Johnson. Hi.
Hi. Hi.
Hi, Miss Johnson.
Hi, Xander. Thank you. That was really creepy, Xander. Okay, so now we've got an angle, and the included side. So angle, angle, and since the side was between those 2 angles, I've got to put it there. That was for the bottom triangle. Now for the top triangle, I've got an angle, and the included side. They match. Angle, angle, and notice I put the S in the middle because the side was in the middle of the 2 angles. All right, that is obviously one of them. Angle, side, angle. Dude, super loud. Thank you. Okay. What questions do we got? Any? None? Am I talking to myself? I know I'm not. I see lots of you in here. Man, I miss you all. Look, we got Xander, Olivia, Mackenzie, Connor, Jackson, Alec, Hannah, Liz, Babjeet, Allison. Okay, let's keep going then. On this next one, there is something that we need to fill in. There's actually 2 things we need to fill in here. One of them, whenever there's a shared side, bam, mark it. That shared side is congruent to itself. It's the dumbest thing ever, but it's true. And if this over here is a right angle, and that's a straight line, it means the other side is a right angle too, because those 2 together make a straight line, which is 180 degrees. So now let's see what we've got. I've got this side over here, I've got this side over here, and the angle between them. So on this one, on the left side, I've got 2 sides that are marked because they've got the tick marks, and there's an angle marked between them. And then on the other triangle down below, I've got the same 2 sides, 1 and 2, with a 90-degree angle between them. So two sides with the angle that matches between them. Bam, side angle, side on both of those. Okay, let's look at the next one. Yay, we're getting closer. There's not a ton left. Okay, state if the two triangles are congruent. If they are, state how you know. All right, there's nothing to mark on this one. You really only mark them if they are touching. And you can write that down if you want to. You only mark anything that is actually touching. And yes, I have gone to Swig already today. Guys, I go there every single day. It's disgusting and I love it. Okay, so if I were to mark this thing, I've got two sides, bam, bam. But the angle is not in between them, people. Now, you might be thinking, well, Ms. Johnson, it is between them on this side. Yeah, but there's two angles between them on this side. I'm talking about the angle that's directly between them, okay? And if it's not directly between them, then it's not side, angle, side. That's not what's going on here, okay? What we've got here is the swear word where we've got an angle side, side. And we are not going to use that because there's no ass in math, okay? So on this one, doesn't work on the left triangle, okay? Remember, we're not allowed to use side, side, angle, or angle, side, side. On the other triangle, again, you've got the two sides and the angle's not included. So this one, side, side, angle. Over here, side, side, angle, or if you want to be silly and write it backwards, that's up to you. But notice it's not one of our reasons because it's not a congruent statement. So not congruent. All right, let's move on. All right, looking at this one. Yay! Find the distance of segment AB. Then we're gonna find the distance of segment BC, CD, and DA. And you're gonna round all the answers to the nearest tenth, and the last, oh, not the last problem, one of the last problems on the test is to add them up to get the perimeter. So if you're having trouble on these ones, I want you to make note of this. You can sketch it on there if you want to on a sheet of paper. Hopefully you all have something to write on right now. That would be helpful. If not, you can always refer back to this later. I'm going to start by finding the distance of segment AB. So I'm going to draw in a right triangle around it. The sides of this right triangle are 2 and 1, 2, 3, 4, 5, 6. So if those sides are 2 and 6, then I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. Now, how do I use that Pythagorean theorem here? Well, if you remember, the right angle always points to the hypotenuse, C squared. So that distance, AB, is the hypotenuse of this triangle. So these two sides, 2 and 6, can go in the A and B position. Someone had the hardest time on number 12. Thank you. We will be really careful when we get there. Someone else was asking a question. Go ahead.
Oh yeah, so isn't B 2?
So good question. Yes. Also, B could be 6. It really doesn't matter which one you put as A and which one you put as B because you're just going to add them together anyway. Does that make sense?
Okay. Yeah.
Okay, so I'm going to put, I'll do B as 2. I'm going to go 6 and 2. So that would be 6 squared plus 2 squared. And I know these in my head. You're lucky. And that's going to give us that distance squared. So 6 squared is 36. Oh boy. 2 squared is 4. And that is still C squared. 36 plus 4 is 40 equals C squared. And how do you undo a square? What's the inverse operation of squaring? It is, where's my pen? There we go. Square root. So I need to do the square root to undo that C squared. I don't know what the square root of 40 is. I'm going to go back to my calculator. There's a lot of stuff on here. Square root 40 equals, do you see how we got 6.3? That's what I'm writing down. For AB, it is 6.3. Okay, let's find another one. Let's find BC next. I'm going to switch colors and I'm going to go to blue. And BC is from here to here. So if I count those, I've got 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. So 6 and 8 are the sides of this thing, and then the hypotenuse is what we want to get. So if we've got a squared plus b squared, oh boy, that's not a 2, plus b squared equals c squared, and then we've got 6 squared plus 8 squared. Sorry for the handwriting. It is really difficult to write with a mouse. Okay, that is 36 plus 64. If anybody's got a calculator handy, you can type that in. Equals c squared. 36 plus 64, 40, is that 100? I think it's 100. Thank you, Allison. Okay, so we've got 100, which I love because 100 square roots very nicely. When I take the square root of that, I will come over here, not to the date, oh my goodness. Okay, I will come over to my calculator and I'm gonna type in square root of 100. Bam, it's 10. So that means that distance from B to C was actually 10. Oh. So 10 equals C. Okay, now yes, it says C there. That's just because I was using the letter C to talk about that distance between B and C. Now, I'm gonna scroll down. You see how all this stuff freezes on there? It's annoying, but that's okay. All right, so I wrote my 10 there, and then we wanna find CD next, and then DA last. So let's try to line this up nicely again. Okay, CD, let's choose a color. Oh man, we haven't done red. Let's go for red. On CD, it goes like this and like that. Now, if I had done this well, that would look like a straight line. Right now, it looks like a blob line. That's okay. Okay, we got a 2 there, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I really hope I counted that correctly. Someone correct me if I did count it wrong. Now I'm like second guessing myself. That's okay, Mackenzie. Okay, thanks, Allison. 12. Mackenzie, I'll post this later, so if you have to leave, that's fine. We've got a squared plus b squared equals c squared. And I'm going to be saying 2 squared and 12 squared. Again, if you did 12 squared and 2 squared backwards, that's fine, because you're just adding them together anyway. And that equals c squared. 2 squared is 4. 12 squared, 12 times 12 is 144. And that equals c squared. When I add together 4 plus 144, I get 148, and that equals c squared. And as always, I take the square root to undo squaring. So if I type in, oh, this page is getting weird, 148 square root, I get 12.2 is what it looks like there. Whew. Okay, so I can come back over here and type in 12.2. Now, this last one, find the distance of DA, and then the hint, count how long the line is. Guys, how long is that line from D to A? You just have to count it. 1, 2, 3, 4, 5, 6, 7, 8. That's my answer. Okay, now, a couple of you were saying that number 12 was really difficult. Let me finish up really quick here, just reminding you, we found the distance of each of these 4 sides of the quadrilateral. So now I've got all those distances filled in here. Now what I'm gonna do is add together all 4 of those to get the perimeter. Hint, add everything together. So I'm gonna use my calculator, and I've got 6.3 plus 10 plus 12.2 plus 8. So 6.3 plus 10 plus, I already forgot the other ones, 12.2 plus 8. And I get 36.5. So I come back over here for the perimeter, 36.5. And that's my final answer for the perimeter there. That's how long to go around the entire quadrilateral. Okay, questions number 13 and 14 are our last 2 questions. And all we have to do, thank you, Alec, that's good to know. All you have to do is the not Pythagorean theorem, the distance formula. And hopefully you have the distance formula written somewhere nearby. So I'm going to write out the distance formula over here, and I'm going to go with blue this time. So I know for my distance formula, D equals the square root, oh man, I'm trying to remember how we wrote it down. You know what's a really great way if you ever forget? Type it in here. Distance formula, not a calculator. X2 minus x1 plus, or squared, plus y2 minus y1 squared. I can't remember if we wrote the y stuff first. That's what I was trying to remember. Does anybody remember? Did we write y2 minus y1? It's okay if you, okay, Allison said yes. So I'm gonna write it with the y's first. Y2 minus y1 squared plus x2 minus x1 squared. And obviously I underestimated how long I needed my square root to be, but now it's the right size. Okay, so then, like we did with slope, I'm gonna mark up these things. I'm gonna call this x1, x2, or excuse me, y1. I always do that. x1 and y1, and then we've got x2 and y2. And the reason we label them like that is because this is the first coordinate you're given. So that's why you go x, y, mark them both as 1 for the first. The second one is x, y, as always, but we mark them both as the second in the world or whatever. Okay, so then the next part, D equals big square root. And instead of y2 minus y1, I've got to put those numbers from up above in there. So my y2 number was a 4. Then I'm subtracting my y1 number, and if I look at my formula, y1 was over here as a -8. Notice that I wrote the negative, because if you just have minus, then you would be treating it like a +8, and that is not proper. That will get you the wrong answer. So you had to go 4 minus a -8, okay? Then let's look at the next part of it. On the next part, I've got the plus sign, but then I open up my parentheses, and now I'm subtracting my x values. So my x2 value is -4, and then I subtract my x1 value, which was 2, and close my parenthesis and square it. Okay, there's gonna be a little bit of math here. So, and that stuff's fine, you can leave it up there. Hello, that was probably unnecessary. Okay, let's type this in then. We've got 4 minus -8. I actually don't know how, I think you can type in 8. I don't know if they give you a spot on here to make it negative. Great question. I'm guessing you can say 4 minus -8 like that. And I just use the subtraction sign for a negative there. So 4 minus a -8 is 12. I wonder if you were to just type in 4 minus a -8. Oh yeah, it still gives you 12. So apparently the parentheses were not necessary. But that means on this side, the 4 minus the -8 was 12 squared. Plus, and then the next part that I need is -4 minus 2. So -4 minus 2 gives me -6. So I have plus -6, and I'm gonna put this thing in parentheses because remember, that's still getting squared. You wanna remember that the negative is a part of that 6 that's being squared. So when I do 12 squared, and then I do -6 squared, I've got 144 and 36. So I'm adding up 144 plus 36. And when I type those in, 144 plus 36, I get 180. Okay, as always, to end these problems, I gotta take the square root. So the square root of 180, I'm gonna have to approximate this thing. Square root 180, and I get 13.4. So my approximation, 13.4. Okay, I went through that one really, really in depth, very, very slowly. And thank you for the, Allison. I went through that one really slowly and in depth, and I am gonna do the next one now. But I won't color code the next one because that took a while. So let's write down the formula again. Oh, I should have left it up there. What was I thinking? Okay, so we know that the distance formula is going to be the square root, I made it bigger this time, and we're doing y2 minus y1 squared plus x2 minus x1 squared. All right, then I need to label those things in my problem. So I said I wasn't gonna color code. You know I can't not do it, man. X1 and Y1 for the first ordered pair, and the second ordered pair is X2 and Y2. All right, so now I can put those things into the formula. So my Y2, which is the first thing I need, is 12. My Y1, which is the second thing I need, that one kind of looks like a 2, is 7. So if I go parentheses, that's not the same blue, that's okay. 12 minus 7, and then squared. Now remember, that 7 was positive. That's why I'm subtracting just a regular 7. Then add that to x2 minus x1. So 5 minus, and then my x1 is a -1. Remember, gotta put both the negative and the subtraction sign. Okay, so 12 minus 7. If I do 12 minus 7, that's a pretty easy one. 12 minus 7 is 5. And then if I do 5 minus a -1, I get 6. So we've still got d equals square root, but now it's going to be 5 squared plus 6 squared. And it gets pretty simple from here. 5 squared is 25, 6 squared is 36. And when I add together 25 plus 36, I get 61. So I am just taking the square root of 61. Last step, square root of 61, and I get approximately 7.8. So I go back to my answer here. I already forgot what it was because my memory is like 3 seconds. 7.8. Oh, down here, 7.8. Okay, that was every problem on the entire practice test. On the test and on the retake, it's going to be just like that, where you are going to do 14 problems, and every problem is going to correspond with how it was on the practice test as well. Questions, if you've got them, type them in. I'm going to clear this out. I'm going to show you a submitted test, and we will make sure that this was 100%. Apparently, we got 19 out of 19. Congratulations. With your math teacher, you were able to ace this practice test. Go through, look and see how you did on the practice test, and if you're feeling good, I will have